What's the matter is our introductory activity to what we are going to be defining as matter and the properties of matter. Our objective is to understand that all matter has properties of mass and volume. We should be able to determine whether something is or isn't matter. And we should use, we're going to learn about the terms mass and volume and learn to appropriately measure mass and volume. So first off, in your groups right now, in the groups you're in, take a look at the top of the What's the Matter worksheet, and there's a few different things. There's a few different items and a few different things up here in number 1. So you guys are going to do in your groups right now is you guys are going to discuss each thing, and you guys are going to place it in one of these 3 categories. You're going to want to say matter, not matter, or if you don't know, that's fine. Okay? So I'm going to pause right here, and why don't we go do that right now? So what do you guys think? Pretty easy? Anybody unsure of anything? There are a couple ones that are pretty are tough to classify, I think. So, well, let's get our matter definition. So you guys are going to want to take this down. I'll read through it first, and then I'll pause, and you guys can take it down. Okay? So matter is defined as anything that has the properties of mass and volume. So mass just measures how much matter is present. Essentially, you're measuring how many particles are there. That's what mass measures. Indirectly. So if I have more mass, I have more particles of a substance. If I have less mass, I have less particles of a substance. Volume measures how much space the matter occupies. So, and we measure those in like a graduated cylinder or a beaker. You can measure that volume in. So I'll pause for a second. So guys, units are very important. If we're measuring mass, the normal ones we're going to use in our class are grams, kilograms, or milligrams. Mostly grams. Okay? Antonio, can you just keep your head up, please? Volume, the usual ones we're going to use are liters, milliliters, and centimeters cubed. And as I just demonstrated, a milliliter and a centimeter cubed, they're 1 to 1. They're equal. So if I have 10 milliliters, I have 10 centimeters cubed. So you can use those interchangeably. Normally, if you're talking about like the volume of a solid, you might say measure it in centimeters if you're measuring a regular shape. And you'd say, okay, that'll be centimeters cubed. If you're measuring a liquid, you're normally measuring it in milliliters. So, but they're equivalent. Moving forward, matter can be a pure substance. Bold words are words that you guys should like underline, put stars around. Those are important words. So, matter can be a pure substance or a mixture. So, take this down, and I'll go through it in just a second. 2, 1. Pure substances, guys, they're only made of a single type of particle. So both this here, if you guys look up here, I have my bismuth and my iron pyrite. Bismuth, you notice, is on the periodic table. It's atomic number 83. I passed out periodic tables to you guys last class, right? Okay. So every single element that we use is on the periodic table. So if it's on the periodic table, it's an element. Okay, bismuth is an element. Now, iron pyrite is made of iron and sulfur. So it's 2 separate elements. It's made of iron atoms and sulfur atoms. So that's why iron sulfide or iron pyrite is a compound. I think there's a couple other things in that. I'm not the mineral expert. But a mixture is made up of more than one type of particle. A mixture can be an element in a compound, 2 elements, 2 compounds, etc. Okay? So guys, what do you think the cherry Coke is going to be? Is that a pure substance or a mixture? Definitely a mixture. There's a bunch of junk in there. There's sugar, there's caffeine, there's artificial coloring, there's cherry, which we are going to remove because I don't like cherry Coke. I just like Coca-Cola. I don't like the cherry. I'm just going to take it out because I don't want to drink it. I'm just kidding. I'm not going to drink it afterwards. That's very bad practice. Never have any food product near the lab benches. All right. So a key thing is if you only see in the formula, if you see just one element, that means it's an element. If it's more than one in the formula, it's going to be a compound. And I'll go through that more later, okay? So this is the matter tree. You guys don't have to copy this down, okay? So I have a question. Can you be a mixture and a compound? No. Why not? What's it? Can you repeat that? Well, a mixture has not necessarily just elements, but it can have an element and a compound. But what is pure substances are elements and compound. If you're a mixture, you can't be a pure substance. And tell me if you keep your head up this way. Just sit up. Thank you. So it's like you guys studied biology last year, right? It's like, can you have a snake that's also a mammal? No. Why? Because snakes are reptiles. They're under a separate branch. Okay? Kind of like how all matter, all snakes are animals, right? And all mammals are animals, all reptiles are animals. But we classify them further, and like reptiles, you could have snakes under there. And mammals would be something different though. So you can't have both. Okay? And we even classify our matter tree a little further. You know, our elements, we have metals, nonmetals, metalloids, noble gases. Noble gases are really nonmetals, but so we can keep on going further. But for our class, what we should really know is that pure substances are elements and compounds, and impure substances are mixtures when you have more than one substance present. Okay? Does that make sense, guys? Good? You good, Gabby? Okay. Phases of matter. This is something you guys should know. Copy this down. This is important. So we'll take a break here. I'll pause this and we'll pick it up in a second. So, solids. We're familiar with solids. Solids have a definite shape and a definite volume, right? Here, let's put that down. Liquids, they do have a definite volume we can measure, like we did with the graduated cylinder before in the cube, the 1,000 centimeter cube. But they fit the shape of their container, right? So if I pour a liquid into there, it's going to fill the container up to its volume, but it's going to take the shape of that container. So it doesn't have a definite shape. So like if I took Cassidy's water and poured it in something different, it would be a different shape, wouldn't it? Now, gas, interestingly enough, has no definite shape and no definite volume. It expands to fit the container. So if you say we had nothing, say we had a vacuum, and we put a little bit of gas, the gas would move around so it fills the entire room. Okay? So the chemist is the internal optimist. Have you guys ever heard the idiom that an optimist says the glass is half full, and a pessimist says the glass is half empty? You guys heard that? Yeah. Now, a chemist is the ultimate optimist because the chemist knows that a glass is always full. There's always something in there. Henry? Oh, go ahead. Just sign up. So, moving forward. Oh, and plasma, which I just showed you in that demo, it's a high-energy ionized gas, which we don't see on this planet too much. We see it when there's lightning. Henry, can you just write a pass up? Sign out and write a pass up. Yeah, and make sure the pass is in pen. So moving forward, you guys don't have to copy this down, but this will help you guys visualize it. So a common misconception is that a solid, the particles aren't moving. And the particles are moving. Just look up here for a second. A particle, and make sure the pass is in pen. A particle in solid is always vibrating. So the particles are always in motion. But the particles in a solid, they're just moving in place. Has anyone ever been on the T in Boston? The train? The green line, the red line. And anyone ever been to like a Celtics game or a Bruins game or Red Sox game and taken the T after that? Can you never? Well, okay. So you should. It's a good experience. You'll feel like a solid. Try moving in that train. It's impossible. You're packed in there. You can like move a little bit to the left, to the right. You can turn around, but you can't. It's hidden pen. Here you go. Write it in pen. Write it in pen right now. Come on. And sign out. So a solid, the particles are moving, but they just have nowhere to go. They're just vibrating in place. Whereas a liquid is like the end of the green line after the Celtics. It's still pretty full, but you can move around in the green line a little bit. It's still pretty packed, but you can get from one place to the other. Thank you. And a gas is like just like a couple people in a whole train car. You guys can move as much free as you want everywhere. So that's what the phases of matter are. And plasmas are like a gas, and we're not going to really talk about them too much in this class. But it's good to know. Gas is matter, guys. Gas is matter. Air is matter. Okay? So there's this scientist, Joe Priestley. He basically was one that he studied early chemistry and made some different apparatuses, and he basically figured out that gases matter because what happened was he had this upside down bottle, and from there was a tube connecting a sealed Erlenmeyer flask with some chemicals inside that. So what he did was he hypothesized that the reaction released gas. So what Priestley did was he connected that flask to that tube to collect the gas. And he found that when it produced gas, the gas produced pressure and bubbles, and this level of the liquid went down. So what does that tell you about gas particles? What do you think, guys? They move around. And also, what property of matter do they have? They have weight. What else? What's the other one? Volume. Good. So they take up space. So they must be matter. He was indirectly credited with inventing the whoopee cushion. Because what he would do is he would, way back when scientists, we didn't have the Flynn catalog. So they couldn't just, hey, Flynn, I need a gas storage device. Can you send me 2 gas storage tubes? Thank you very much. They can't do that. So what they did was they took, they went to the butcher and they took pig bladders and filled them with air. So indirectly, I know, kind of gross. I prefer a whoopee cushion. But that's how he stored his gases in pig bladders. So he collected these gases and put them in a pig bladder. The pig bladder filled up, kind of like a balloon, more like a balloon, and then stored them right there. So that's one thing I also wanted to mention. We're going to see a lot of reoccurring themes in chemistry. So look up here for a second. Okay. So it also has to do with energy. So say we have the same substance. A solid has the lowest energy level. As you increase the temperature or increase the energy level, you'll turn into a liquid. As you keep on going up, you'll become a gas. And plasma has the highest energy level of them all. But normally and those take very specialized conditions, like a microwave. You have to pump in energy and particles have to absorb it. But energy is related to all this stuff. And I know you guys talked about energy in bio, right? You guys talked about how when you take ATP, your body uses enzymes to convert that to ADP. What happens? You release energy. And for us, that's an energy in the forms of biological function. Like our bodies do work. Like I can lift up this pen and I can throw it over at Henry if I wanted to. That's converting energy, chemical energy to biological energy. So listen for that theme of energy. We're going to be discussing that a lot. All right, and let's stop